For the next session, I'd like to welcome our speakers, Dhairya Thakker and Sakthikannan Subramanian. Dhairya is a QA manager at Cognizant. Sakthikannan is a SDET Scrum Master at Cognizant. Today, both of them would be speaking on the topic cloud testing. Let's test applications in cloud platform and how different is our approach. To know more about them and to see their video interviews, please check out these links on the screen. I'd now request Dhairya and Sakthikannan to take ahead this session.
Yes, before that, I want to I want to say what I'm saying. Dhairya and Shakti and then lightning. Wow. Nice, right? Dhairya, Shakti, and lightning. Wow. Yeah. Go ahead. It's yours, follow.
I think Dhairya will not give me a pain of sharing the screen again. I think you're ready, Dhairya.
Yeah, I'm ready. So hi everyone, my name is Dhairya Thakker. I have around 15 years of experience, last 5 years with Cognizant, worked across different geographies, different clients, and so that's me. I think let's straight away get into the slides and let's start rolling. So Shakti, would you like to give a start first?
Yeah. So the cloud testing. So when it comes into cloud testing, it's like we were like monolithic few years before, and we moved from monolithic to microservices, and these microservices is getting executed or hosted in the cloud systems. To test this, what we did, like how did we move from a monolithic kind of ways of testing, like deploying services and deploying your websites to a local website or a non-production website and start testing on that, and then you find the bugs and go back to your developers and say that these are all the bugs, can you please fix those things? That's really an old way of working, like inventing like kind of like a wheel. For me it's kind of like that. So now it is kind of like when we talk about an agile team, it is like developers and QAs, it's kind of like completely pairing. So how your developers develops, like using any Kubernetes pods or using your Docker images and stuff like that, Docker pods and stuff like that. So same way, you have to travel along with your developers as well, saying that, okay, I too have my local setup for all those pods. I too have my local setup for all those websites and stuffs like that, so that I can start validating stuffs. I can start testing stuffs in my local itself. So when I do this, so what is the kind of like test share that I'm going to validate, right from the unit testing to end-to-end testing? So how am I going to validate? What is my approach? What is my share? How is my unit test? If you think about this testing industry pyramid, you can think about what is the share of unit test, what is the share of functional, how I'm doing this contract testing, or how I'm doing this integration and end-to-end testing. Along with, I have to implement these NFTs like security or performance kind of tests as well to my testing life cycle. So how am I doing that? How can you do everything in a shift left model rather than pushing everything at the later stages? So that's what we're gonna see, and how did we implement all those things. Over to you, Dhairya.
So yes, as Shakti was saying, this is the pyramid which we are talking about. So you can see we have functional testing, then contract testing, non-functional testing, SIT testing, and end-to-end. So as we go up the pyramid, wherein as an end, more and more components starts getting added. Because if you see end-to-end, it is now an industry notion that end-to-end or SIT testing, they are very costly. It is very difficult to fix a bug when you discover a bug at SIT or end-to-end level. So it's like, so if you can cover, or and as we say, there is this word called shift left. So why not kind of test everything at lower levels, at unit test level or at functional level, by just spinning up what you need to spin up your service, test everything there. And when you're okay, yes, it is working what is expected. And then that's how you gradually climb up the layer. And then you think of, okay, I need to do non-functional testing like performance or device compatibility or accessibility or whatever. And then there is a final SIT or end-to-end testing where you have real components, and especially because everything is like gone are the days when you used to have a server and kind of you will get a mail, please drop this file on this service. We are way past that. Things are now on cloud. Spin up a container, spin up a machine, spin up an EC2 instance or whatever, deploy your code there, run it, and that's it. That's how we are talking about, because that's how the microservice world works today. It's not only microservices are not only backend, because even I think there very soon there is a micro front end things coming as well. So everything is into small chunks, small components. Test them; they are individually working fine, and there are guidelines. And then at SIT level there will be issues. We'll cover more in the slide going forward. But this is what we mean when we say testing in cloud. If I go to my next slide, so let's this is one diagram. This is one because we day in day out we work with AWS platform, so we know this is how it looks. So this is one because in AWS you have something called AWS Lambda. So Lambda is nothing like a function. It's like a function. Okay, it's like if you can call it a service, but you can call it a function as well. It's like a method which has a handler, and beneath the handler there is a set of code which runs. It's as simple as that. Now that handler can be invoked. It has an event mapping. So on the left hand side you can see I've given a series of 2 blocks. One is API gateway, one is AWS SQS. There are more, but for the illustration purpose I've just given 2. Like you can invoke a Lambda with an event mapping, like when it gets an event from an API gateway, or when it gets an event from a queue. That is, you push a message onto a queue and the Lambda gets invoked because it gets an event notification. Hey, something is there in the queue, pick it up and process it, something like that. On the right hand side is this Lambda needs certain other bits, like it has a data repository layer, and so like there is an RDS. What is RDS? RDS is nothing but a data DB hosted on a cloud. Or maybe it needs to process something and push out something and let the world know I have processed this. So it has an SNS notification. Or it has NoSQL based database like DynamoDB. These are again typical AWS components we are talking about. And for it might need to talk to some external services. It could be again AWS Lambda or a Spring Boot service, anything. So this is just one example, one illustration how it works. The second one, I'll move to the next slide. So let's say here this is more on a Kubernetes platform or Kubernetes cluster. You have a Spring Boot service. That Spring Boot service might be talking to other Spring Boot service or AWS Lambda as well. Same, it has its own set of database. DB1 is RDS, non-DB1 like DynamoDB, and the notification type SNS. Spring Boot mostly we know comes via API gateway. That is, you make a get or a put or a post call, primarily a CRUD service or something like that. So how do you test these services in today's world? So we have this thought process, like what is used to develop these services. The same libraries can be used to test it. It's like cloud development kit, or in AWS world, we call it AWS SDK. There are similar for GCP and Azure as well, but we call it cloud development kit or AWS SDK, which is available. You can, like whatever your build tools, be it Maven or Gradle or whatever, you can simply use it, download it. Now, these cloud development kit is used to develop your application. The same kit can be used to test it. The same kit is used for unit testing purpose as well. And the same kit can be used good enough to test it in functional or integrated environment. Yeah. So say, for example, like how do you, like, as I've just mentioned, like we have different layers of test. One is functional, where you have mocked up. All your external dependencies are mocked up. And one is your integration layer, where everything, you have real instances to which your service talks to. So in real instance, when I say real instance is so you have an AWS account and you have a real RDS instance or a real DynamoDB instance sitting there, and your actual service is talking to it. That is an integrated environment. Of course, you need to pay for that because you have spun up an instance. That instance costs money. But then there is a functional aspect to it, that before even I go to that level, do I know that my service is actually able to work with the DynamoDB correctly, or my service is actually able to push a notification to SNS? I can spin up local containers. Everybody knows nowadays, like there is Docker widely available, or Colima, or there are many container services available. So you can, and there is a very well-known Docker image called local stack, which is a local version of AWS component. So you can spin up a local version of your SNS or SQS or RDS or DynamoDB or whatnot. Everything can be spun up locally using that. So I'll go to my next slide. So this is like, because the diagram will speak more words. So say you have either a Spring Boot service or a Lambda service or whatever, which is under test. Now it has external services, which could be again a Spring Boot or a Lambda service. At integration layer, you are actually talking to a real service, but at the functional layer, you can simply create a warmock, spin up a warmock instance in Docker, and provide your mappings there, and that's it. And same way for the other AWS components, like be it DynamoDB or API Gateway or SNS or SQS. You can use the real ones when you're doing the actual end-to-end test. But when you're doing a functional test, you can simply spin up a local stack image and mock all the components. Same for all these major database like MySQL or IBM DB2 or Postgres. For all of them, you have a Docker image available. So when you're running in a mocked environment, you can create a container for them. Or when you're calling an integrated environment, you can actually call an endpoint, or as we call, right, you normally would have an endpoint or something like PostgreSQL : 5432, things like that, which is a actual instance you are talking about.
Should we go for questions?
We'll come to that. I mean, just two figures, so in the right-hand side, again, what I was saying, like in the right-hand side, you have local stack. Anybody who's familiar with Docker Compose would realize that this is a local stack image, and I'm spinning up services like SQS and SNS, and I'm just giving a default region and port mapping and whatnot. So this is for functional testing, but when you are actually doing an integration test, whether your service is actually allowed to talk to this resource in a real environment, for that you are actually testing this part of your stack. So if you have a CloudFormation script, probably you will have something like this in your CloudFormation script, which is a YAML file, where you are talking about whether this particular service is actually to receive a message from an SQS. Say this is an SQS resource, which is uniquely how it is known in that particular environment. So the thing is, my service can talk to a queue. I can test that functionally before even spinning up a actual queue in an integrated environment. And my service is allowed to talk to that queue. I can check that in an integrated environment. So there are two aspects of testing. One, my service can talk, and my service is allowed to talk. So these two things we can validate. One is a functional aspect, one is an integration aspect. So this is how we have broken up our test and broken down majority of our test components or test constructs in the lower environment, like functional environment, where everything is mocked, no money is required there. And when you are actually testing the real components, you by default know, yes, my service is good enough. I'm just checking the permissions are okay or not, or if I'm missing anything or not, something like that. That's it. I'll stop sharing.
Okay, audience, we can take questions. Okay, 2 questions. Rather typing, unmute yourself and ask your questions.
Looks the area is clear enough.
Yes, lighting is cleared. Yeah, nice. So, Shakti and Dhairya, I have a question now. Okay, like I was getting this question. Okay, when I was listening to you, what means what skill of programming is required for a tester to do these steps? Because like I can see testers who are not programming, but they want to do this. So what should be their approach, and what is that skill they require?
Shakti, do you want to answer that, or I can take that?
Yeah, so it's two things, Surya. One is like, if you ask me, being an SDET, you'll have to kind of like, you need to be kind of like an aware of the tech stack that your organization is having. If, let's say, I have recruited a buddy QA for my team, and expecting that he should know everything that my fellow QA, experienced QA, that's quite hard. So in that case, two things. One is like the experienced SDETs, they need to kind of like enable them to make sure that they need to work on this tech stack, because here we are talking about all those most of the technical buzzers like mocking and Dockerizing and creating some Kubernetes docs and stuff like that. So which quite need some technical stuff. So where the budding QEs or QAs, they need to kind of like pair up with their developers or existing SDETs to do these steps. So sessions like this will enable them to think about these kind of works are there, or these kind of possibilities are there. So this will kind of like enable them to talk with the fellow seniors or fellow developers to say, why don't we implement such technology here? Because if you think about most of the organizations, you can see like they will say like, I need 4 days to complete my regression testing. I feel like we are in 80s and 90s, but we crossed that stage, right? So these kind of setups on the cloud testing and things like that, which is Dhairya was rightly saying that it is kind of like pushing things to the down in the pyramid, that is shift left or shift down model, where you will kind of implement such technologies and work along.
Okay. Sure.
Of course, but of course, right? So being a QA to QE transformation, that sure requires the technical knowledge. Scaling up is really very important here, actually. Yeah.
With that, we'll end this lightning talk session. Have I land out to my team member, Murunmai? She came in lightning speed. Yeah, good. Yes. Yes, man.
So with this, we end our last lightning session. Thanks, Dhairya and Sakthikannan, for this informative session.